Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago.
Imagine there is a huge crevice right under your house. What would you do? Probably pick up your belongings and evacuate the structure. This is what happened to one Kenyan back in 2018. A massive crevice formed almost overnight under his home. The man escaped to safety, but the event revealed a deeper issue. Much deeper than most people thought. The crevice appeared after a month of heavy rainfall. This part of the country, west of the Kenyan capital of Nairobi, sits in a seismically active region. The massive hole in the ground was covered with ash from a nearby dormant volcano. The crevice in the ground ran for miles, and it was 65 feet wide in some places. It was as deep as the Hollywood sign is tall. The gaping hole damaged a vital local road. People soon dubbed it the Grand Canyon. But this is no laughing matter. The same thing happened in 2023. Kenya's highway authority had to close the busy road for repairs once again. Preliminary reports showed that heavy rains were the likeliest cause. The rupture itself is part of the Great Rift Valley. It extends from Jordan in the north to Mozambique in eastern Africa. Its total length is nearly 1.5 times the distance from New York to Los Angeles. Rift valleys are located all over the planet. They're lowland places where tectonic plates move apart or rift. These are huge slabs of rock in Earth's outermost layer. They rest on molten rock underneath, which makes them unstable. Tectonic plates are constantly on the move. They can bump into each other, or one plate can go under another. This can occur both on land and at the bottom of the ocean. Continental rifts are less frequent than the ones we find underwater. The East African Rift is one of 4 major ones. The nearby Arabian Plate has been on the move for the last 30 million years. When it separated from the African mainland, it created the Red Sea and the Gulf of Aden. When you look at the physical map of Africa, it looks like one contiguous landmass. But when you dig deeper, quite literally, you realize it rests on 2 tectonic plates. The Nubian one carries most of the continent. The smaller Somali Plate holds the Horn of Africa. The crevice in Kenya appeared in the rift valley between these 2 plates. That's because they're moving away from each other. The rift is growing larger, which means that one day the African continent will split into 2. The rifting process is a slow one. The present rate is just 1/4 of an inch every year. Scientists estimate that the split will occur in 5 to 10 million years. Some experts place this event 50 million years into the future. The end result will be 2 African subcontinents. They will be separated by a body of water that will become our planet's 6th ocean. This also means that 5 now landlocked countries will get access to the sea. When they get a coastline, the countries could build harbors to trade with the rest of the world. 3 other countries, including Kenya, would find themselves on 2 continents. The future split of Africa into 2 parts might sound dramatic at first, but it wouldn't be unnatural. This is the first time, after hundreds of millions of years, that the shape of Earth would change so much. The last time this happened was during the Jurassic period. If you're now thinking of Steven Spielberg's 1993 blockbuster movie, you're right. The world of dinosaurs had a different shape than the one we're familiar with today. There was a supercontinent called Gondwana. It included today's South America, Antarctica, India, Africa, Arabia, Madagascar, and Australia. Then, around 180 million years ago, things started to change. Earth was starting to take its familiar shape. The Indian subcontinent collided with the Asian mainland. The event gave rise to the Himalayan mountain range. These are the highest mountains in the world, with 30 peaks over 24,000 feet in altitude. This process is far from over. The Himalayas are still growing in height. On the other side of Gondwana, Africa and South America first separated together. But they weren't meant to last long. 40 million years later, South America started drifting away from Africa. This created the South Atlantic Ocean. The evidence of this ancient continental drift is obvious to this day. If you look at the map of South America, you'll notice a bulge in its eastern part. That's the modern country of Brazil. On the other side of the Atlantic, Africa has a huge inland curve on its western side. The 2 act as pieces of a giant jigsaw puzzle. They roughly fit into one another. European scientists noticed this as early as the 17th century. Further research confirmed the theory that South America and Africa once belonged to the same landmass. This is only one part of the story. At the beginning of the 20th century, a German scientist came up with the theory of continental drift. He believed that all of Earth's continents were once part of a supercontinent called Pangaea. The name comes from Greek, and it means all of the Earth. Makes sense, doesn't it? It was surrounded by the oceanic ancestor of the Pacific Ocean. Some 200 million years ago, this gigantic landmass was home to many animal and plant species. Thanks to them, scientists could piece together what our planet used to look like. For example, Mesosaurus was a giant freshwater reptile that existed during the Cretaceous period. Paleontologists found its fossils in only two places, Africa and South America. The animal lived in fresh water, so there was no way it could have swam in the Atlantic Ocean. This pointed to the fact that it lived in a single habitat, rich in rivers and lakes. This would have been possible in only one scenario. The two continents that are now miles apart were once a single piece of land. Pangaea wasn't the only supercontinent in Earth's history. Continents came together and drifted apart several times throughout our planet's past. Researchers know of at least 3 times this happened. Pannonia formed 600 million years ago. Rodinia was an even older supercontinent. It existed a billion years ago. The driving force behind all these changes was tectonic activity. Plates deep beneath our feet have the ability to create new land and oceans. This is what's happening in East Africa right now. This activity is most evident at the bottom of the sea. Molten rock rises from deep within the earth to create new seafloor. The process is called seafloor spreading. It happens along underwater mountains called ridges. One example is the Mid-Atlantic Ridge. I think you can fairly accurately guess its location. Over time, the seafloor grows wider here. This has an effect on the continents on both sides of the ridge. Seafloor spreading causes continents to move away from each other. Right now, North America is moving away from Europe at a rate of 1 inch per year. This doesn't seem like much, but give it 50 million years and the Americas are gonna bump into the western part of Asia. The two landmasses will form a new supercontinent. Geologists from Yale University have a name for this land, Amasia. Talk about rushing before the ore. They ran a series of computer simulations to see what Earth would look like millions of years from now. The new continent is likely going to form somewhere around the North Pole. But don't go shopping for winter clothes just yet. The time frame for this event might extend to 200 million years into the future. India could split horizontally into 2 parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Calcutta and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely 1/10 of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept, the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where 2 or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the sea floor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya. First in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into two subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The two are gradually moving away from one another, which causes the formation of crevices within the Rift Valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into two continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today.
Our planet has 5 oceans: the Pacific, Atlantic, Indian, Southern, and Arctic, not counting Billy Ocean. But it seems there's a 6th one out there too. It's just that you can't see it. Scientists have found evidence of large amounts of water hidden in the transition zone. That's the boundary layer that separates the upper and lower mantle of our planet. That boundary goes hundreds of miles deep down below the surface. Natural diamonds usually form in the mantle, but at depths of up to 155 miles. Some of them are very rare. They may come from deeper depths. That was the case with this fascinating diamond that formed 410 miles below the surface. The gem was big enough for scientists to study it and determine what it was made of. They were surprised when the composition of this very rare diamond showed that it was formed in pretty watery conditions. Because of that, such a diamond wouldn't be worth much in jewelry stores, but it was priceless in the lab. So, could this mean there's an ocean under the surface of our planet? It would definitely get us closer to the idea Jules Verne had about this whole magical secret world inside Earth, including the ocean. But that's not exactly the case. The water is there, true, but it's not like you can enjoy the view watching waves splashing around like on the surface of our planet. The water is actually stored within the minerals. That's why this area is so wet. Let's now move to Africa to keep up with the story, or to be more specific, to a spot called the Afar region. It's part of Ethiopia and a place where 3 tectonic plates meet. Tectonic plates are large pieces of our planet's crust that slowly move. These movements cause earthquakes and produce volcanoes, mountains, deep underwater valleys we call trenches, and so on. And the Afar Valley is where the Arabian, Somali, and Nubian plates meet. Together, they form an intersection in the shape of a Y. Why? Let me tell you. These plates are moving all the time. The Somali plate is moving southeast toward the Australian and Indian plates. The Arabian plate is moving north, getting closer to the Eurasian plate. At some point, it will close the Persian Gulf. This movement of plates has created something we call the Great Rift Valley, considering there are, all these cool rifts. The Aden Ridge to the east, the Red Sea Rift to the west, the Oculus Rift and the East African Rift to the south. But the East African Rift is something we want to focus on, because this one could be the key to this potential 6th ocean, but this time on the surface. A continental rift is a spot where 2 tectonic plates that form a single continent start to separate. Here it's the Somali and Nubian plates. Together, they're parts that make up Africa. If they keep moving in separate directions, this currently continental rift may become what we call an oceanic spreading ridge. In other words, when the plates are far enough apart from each other, there will be an enormous crack between them. This way, magma will freely flow up from beneath them. It'll be cool and eventually start creating a new ocean floor. Africa will be split into two parts, and there will be a new ocean flowing between what will turn into two mini-continents. Nope, it's not time to get your swim trunks and sunscreen yet. Even if the Somali and Arabian plates do move far enough to form an oceanic spreading ridge, it'll take millions of years before this happens. So I guess it's more interesting to stick to exploring this sixth ocean below the Earth's surface for now. The idea of subsurface oceans goes beyond the borders of our planet. It's possible many moons and planets out there have them too. Our home planet is the only one we know about with consistent bodies of liquid water on the surface, true. In our solar system, we circle around the Sun in something called the habitable zone. The temperature and atmospheric pressure within this zone allow water to remain in liquid form all the time. But a couple of moons in our solar system could also contain significant amounts of water under their surface. Enceladus, one of Saturn's moons, is the first one. Enceladus is a small frozen ball, 7 times smaller in diameter than our moon, but it's the 6th biggest moon of Saturn. Nearly a decade ago, a spacecraft found evidence that there was a large ocean under its surface. It found and sampled water from the eruptions that resembled geysers. A geyser is a rare type of hot spring that erupts and sends jets of steam and water into the air. You know, like Old Faithful in Yellowstone? Well, this water was erupting through fissures in the ice at the south pole of the moon. That means there might be a liquid ocean under the thick layers of ice. The ocean there is almost nothing like ours. The ocean on Earth is relatively shallow, on average 2.2 miles deep, and it covers 3/4 of our planet's surface. It gets colder the closer you come to the seafloor, and is warmer if you stay close to the surface because of the sun's rays. But the subsurface ocean on Enceladus is at least 18 miles deep. It's cooler at the top because that part is near the ice shell, and warmer at the bottom because of the heat coming from the moon's core. But both our ocean and the ocean on Enceladus are salty. Enceladus is one of the few places in our solar system that has liquid water, which makes it an interesting spot to search for signs of life. Another one is Europa, one of Jupiter's moons. Scientists think similar eruptions of water could be happening there. Knowing there are such geysers there tells us these moons have their own source of energy. Maybe the energy that makes the water erupt comes from gravity or radiation. The same energy could keep a large body of liquid water under the ice. It could even support some forms of life. There are thousands of planets beyond our solar system that orbit other stars. Some are even in the habitable zone. Over 1/4 of the ones that we know about could have liquid water, but the majority of them probably have oceans under their surface, like Enceladus and Europa. Pluto might be on this list too, since it's possible it hides a liquid ocean under its thick frozen shell. This subsurface ocean likely formed long after the dwarf planet did, after the heat coming from radioactive elements in Pluto's core melted some of its ice. There's also something called water worlds. Those are moons or planets with global oceans that are more common than we thought. I mean, some call Earth a water world too. 71% of its surface is water after all. And when you look at our home planet from space, you mostly get those blue marble pictures. When exploring other planets, especially those outside of our solar system, researchers often go with a policy of follow the water. After all, water is the main element we know that's necessary for supporting life. And when there's a water world that's close to its parent star, scientists assume it must have formed way farther and then moved closer once its orbit shrank. The composition of the planet was set when it was in a colder orbit, or, in other words, when it made a wider circle around its star. We call the process of orbital shrinking a migration, and if water worlds are really that common, it can be proof that migration really happens. Exoplanets are all those planets that orbit around other stars, not our Sun. Some exoplanets may have oceans that are way deeper than any of those in our solar system, hundreds or even thousands of miles deep. Our Mariana Trench is scary, and it's not even 7 miles deep. And those exoplanet oceans are, wow, almost bottomless. You find yourself in Africa, land of unique wildlife, home to a great variety of cultures and languages, and, first and foremost, host to the world's largest hot desert, the Sahara. It's daytime, and you are thirsty for some water and shade. You've been walking for days, trying to find one of those precious-looking oases. You feel you're near, but the horizon just keeps stretching and stretching. Your mind is tired, and your body is feeling all the heat. It's like you've eaten a full plate of hot pepper and then some more, judging by how much you're sweating. And when I say hot, think 100 degrees Fahrenheit hot, on average. No wonder this is happening. After all, you find yourself in the world's biggest hot desert. Now I say hot desert since the biggest deserted landscapes are actually the cold ones, located in Antarctica and the Arctic. Icy Antarctica's frozen desert is more or less the size of 1 million LAXs. Yep, the Los Angeles International Airport. The Arctic desert is just a bit smaller than that. Now, in case you don't know, the Sahara Desert is located in northern Africa, stretching from the Atlantic Ocean all the way over to the Red Sea. It occupies an area large enough to place approximately 100,000 Disney World theme parks side by side. According to scientists, its boundaries are expanding. Deserts usually form in the subtropics because of what's called Hadley circulation. The air rises at the equator and descends into the subtropics. This circulation of air has a drying effect, which helps the formation of desert landscapes. Since the 1920s, the Sahara is considered to have expanded by over 10%. How is this happening? Well, let's start from the beginning. You probably know the Sahara Desert as one of the most inhospitable places on Earth today. Just FYI, for a place to be considered a desert, it has to receive less than 4 inches of rain per year. Due to the very small precipitation index, deserts are usually dry and arid places. There is little humidity in the air, and daytime temperatures can go as high as 130 degrees Fahrenheit. Usually, there isn't that much animal and plant life because of the lack of water. But in the Sahara's case, it wasn't always like that. It may be difficult to imagine northern Africa without the tons of sand it has today. But about 20,000 years ago, the Sahara was actually one big oasis. Recent discoveries show clear evidence of what the scientists now call the Green Sahara. In the mid-1800s, a German explorer crossing the Sahara encountered some paintings and engravings that nomad artists had left behind. What he saw in those paintings looked nothing like his actual surroundings. Instead of an arid landscape with only camels and desert vegetation, the rock paintings depicted jungle animals like giraffes and hippos. There were even images of livestock and grazing animals such as cattle and sheep, something that seems impossible for modern-day Sahara. Artists usually draw what they see around them, so this finding really intrigued the German explorer. The drawings were so detailed that the artists must have had close contact with those animals. You can find this rock art spread out in the northern part of the African continent, from western Sahara to Saudi Arabia. Geologists soon took a keen interest in this and found the first clues to what this could mean. They have been able to confirm that, in fact, northern Africa was once much wetter. They found evidence from nearby deep-sea sediment off the coast of Mauritania. Sampled cores of underwater sand and mud, known as Saharan dust flux, show geologists that, indeed, a green Sahara was possible. The more dust is blowing off of the desert and into the bottom of the ocean, the drier the climate in the region. The sediment cores show that there was much less dust, only half as much, coming off northern Africa during the humid period. This period has to do with Earth's natural cycles. Normally, the Earth rotates at a tilt of 23.5 degrees, but this angle is not consistent and changes over time. Earth's tilt is responsible for the amount of sunlight each hemisphere receives. It affects several ecosystem functions on the planet. During the time of the Green Sahara, the Earth received between 4 and 8% more sunlight than it does today. So when the Earth tilted about 20,000 years ago, the northern hemisphere received more direct sunlight, which affected humidity levels in the region. As the northern hemisphere got warmer, this affected monsoon activity, more specifically, the West African monsoon. Monsoons are wind systems that affect a region's rainfall index and humidity levels. As a part of the globe gets warmer, it allows for more air to rise. It combines with the wind to draw moisture up into the atmosphere. Little by little, northern Africa also became wetter. The increased moisture made the Sahara so wet that there were actual bodies of water in the region. As vegetation grew, the plants held onto moisture better than bare sand could. There is evidence of natural basins throughout the Sahara and lakes so big they would fit all of the U.S.'s Great Lakes inside of them. Archaeologists uncovered evidence of vibrant societies in what are now arid areas. It looks like ancient cultures were able to take full advantage of the African humid period. According to researchers, the human population peaked across the Sahara about 9,000 years ago. There are traces of fireplaces, hunting tools, fish hooks, and even mounds of fish bones. Records show that there have been over 230 green periods over the span of 8 million years. Solar radiation is always changing due to natural orbital cycles. That's why Earth will most certainly see another green Sahara moment. It might be thousands of years from now, but it will happen. The same way the Sahara turns green, it turns yellow again. Let's put it like that. All it takes is a significant axial tilt and a few years of readjusting. However, another phenomenon is calling the attention of scientists now. Recent studies by the National Science Foundation from the University of Maryland show the Sahara has expanded 10% over the past 90 years. This phenomenon is called desertification, which literally means fertile land turning into desert land. The Sahara Desert is now advancing into the semi-arid region of Sahel. In 1950, this region was home to 31 million people. Today, its population is over 100 million people. This rapid population growth has largely contributed to the Sahara's expansion. Farmers that were once nomads began settling down. Land usage grew more intense, aiding in weakening the soil. The demand for food has caused an overcropping of the land, so even more of it is turning into the desert now. The study also shows that natural climate cycles can affect rainfall in the Sahara and the Sahel. Scientists affirm that all deserts fluctuate, not only the Sahara. A desert's boundary may expand in the dry winter and contract during the wetter summer. South of the Sahara lies the Chad Basin. It is a natural body of water that now serves as an indicator of the Sahara's expansion. The Chad Basin is located in the region where the Sahara is advancing southward. An atmospheric and ocean expert from the University of Maryland explains that rainfall has reduced greatly in the entire region. Due to reduced rainfalls, there is less water across the entire basin, and even Chad Lake is drying out. Just like the Sahara, the Atacama Desert in Chile, deemed the world's driest, is also expanding. It is located north of the city of Santiago, and its southern border is expanding toward the Chilean capital. Because the climate is getting drier and drier here, the city of Santiago risks turning into an arid or semi-arid region itself. The once fertile valleys of local rivers that lived on agriculture and livestock for many generations are losing their revenues as Chilean land is turning into a desert. Since 2010, Santiago has received only a third of its annual rainfall. Outside of the city, farmers are digging holes in search of blue gold, or simply put, water. The situation here is very similar to that of Sahel. So tell me this, were you as surprised as I was to find out what has been happening in the Sahara region? Feel free to share in the comments below. You plan to spend your summer vacation in Africa. The final destination is the Sahara Desert. It's located in northern Africa, stretching from the Atlantic Ocean to the Red Sea. You're excited to ride camels and learn about the region's rich cultures. You hop on an extensively long flight, and finally, you are here. You find yourself in the world's biggest hot desert. Can you believe it's 3 million square miles? You're ready for your first adventure after drinking liters of ice-cold water. The guide gives you a choice. You can spend 2 weeks visiting a collection of oases, or you can help them solve an ongoing local mystery. Deep into the desert, near this Algerian town, lies a mystery begging to be solved. A collection of huge, spotted circles in the sand. There are dozens of them, stretching for miles in a straight line. The circles were first identified via Google Earth images several years ago. People have debated them for years, but no one seems to know the answer. The strange thing is that they are so many miles away from any towns, roads, or human activity. The quickest way to discover the truth behind the circles is asking questions. You grab your notebook and set out to talk to locals. Everyone is helpful in this scenario: geographers, anthropologists, elders, and historians. The first person you talk to is a map expert. You need to understand if those circles were authentic or a satellite glitch. You end up interviewing the people who take Google Earth satellite pictures. The circles are really there. They appear in multiple pictures from many years. Then, let's understand why they are there in the first place. After 2 days of interviews, you have your first lead. The circles could be the result of oil activity. Experts explained why this would make sense. Algeria is a rich area for natural resources, so this would be a sensible guess. Usually, to find out if there is anything worth extracting, companies would undertake seismic surveys. Seismic surveys are a way of analyzing the Earth's surface by sending shock waves into the ground. Depending on how these waves bounce back, you'll know what is located there. A special vehicle could have marked the soil that way. So, did we unravel the mystery? Not quite so. As you know, the Sahara Desert is one of the driest areas on the planet. The average high temperatures in summer are over 104 degrees Fahrenheit. To survive there, people need to find ways of accessing water. So, these circles could be a kind of ruin or leftovers from ancient water wells. Again, I'd say this is a sensible guess. Ready for some fact-checking? Some anthropologists agree that these circles could be ancient fogueras. Foguera is the name of a 2,500-year-old style of irrigation system, usually found in northern Africa. It is also known as a qanat in other places in northern Africa. Locals would dig a deep well at an elevated point, deep enough to tap into underground water. They would then dig parallel shafts at regular distances. Then they would dig an underground channel that connected the city to the well. Solely with the help of gravity, water would run from the well to the city. This traditional technology provided water for crops, livestock, and humans. Now, let's say these wells made human-made oases possible. Even the closest municipality name was an indication that this could be true. The name Fogueret Essaouira is actually named after Fogueras, these ancient wells. Now, this lead was proving to be very accurate. You decide to travel over there to see for yourself. You take a local bus, sit back, and enjoy the ride. The landscape in northern Algeria is filled with ancient-looking towns. You even see ruins of wells along the way, on the outskirts of smaller cities. Opening Google's satellite images, you can see the qanat's markings on the ground, a series of holes running down several miles. But as soon as you arrive, you find out you were wrong. Dale Lightfoot, one of the world's leading experts on qanats, said that the circles were definitely not qanats. Even the satellite images confirm this difference. Uh-oh, we were so close. Apparently, qanats or fogueras would not run down a straight line. They wouldn't be shaped like circles. Another clue that this wasn't the case was that there were no towns at the end. The circles were really far away from any human activity, and qanats were explicitly built to provide water for human settlements. Well, it sure was a good try. You almost gave up on this mystery when you decided to take one more field trip. It was days of preparation, pick up cars, food, equipment, all so that the mystery of the Sahara Circles could be unraveled. On the first day, you drove over 99 miles into the desert. You were always curious to see what this part of the world looked like. Over there, you see nothing but mustard yellow dunes. The night sky is pretty decent though. You can see the entire Milky Way with your own eyes. You set up camp and sleep under a canopy of stars. The next day, tension grows. There's no cell reception. Oh dear. But thankfully, you added the coordinates of the circles to your Google map. And surprise, the offline mode works out there. You follow the coordinates, but it leads you astray. You start to get nervous, thinking this was all in vain. But you and the team get into the car and drive a few more miles past the coordinates on your phone. After a very bumpy ride, you can't believe your eyes. There it is, an enormous crater dug on the sand, surrounded by 12 smaller holes. From up high, it looks like a clock, without the pointers, of course. On the ground, they're very faint, so faint you almost miss them. Searching the area, you notice all the holes had something similar: metal wires, thin wires that you can pull from the ground. They're buried deep, so you start digging. An object starts to reveal itself. Uh-oh, it looks like old dynamite. This certainly surprises you. Better stop digging to avoid any accidents. At the end of the survey, you feel satisfied, but still curious. What could all this dynamite mean? And who put it there? What comes next is the turning point of your adventure. Walking back to the car, you see something shining on the ground. You approach the item with curiosity. It's round and rusty and looks like a sardine can. What's that doing here? Could this give you more clues about the circle's mystery? Just in case, you pick it up and put it in the car. Back in the city, the puzzle pieces start to reveal the story behind the Sahara circles. You bring photos and the sardine can and show them to local experts. They analyze your material and give you an intriguing verdict. As it turns out, guess number 1 was the closest one to the truth. So, what happened to the first guess? Why do we need to keep digging deeper? Well, because it was only half right. The Sahara circles are not a historical footprint of seismic surveying. Back when the circles were made, this technology didn't even exist. But they sure are related to oil exploration. The dynamite-filled holes were an old method for oil searching. The circles are the leftovers of surveyors looking for resources underground. And the sardine cans? Well, they were left by the workers who held explosion works. You gotta eat, right? According to the model of the can, this happened more or less around the 1950s and 1960s. So these circles aren't even that ancient. More like modern ones, if you ask me. Well. Hope you are glad you tagged along and helped unravel this mystery. See you in the next mystery-solving adventure. In 2018, the most powerful underwater earthquake occurred between East Africa and Madagascar. There was a deep rift between the Earth's crust and the mantle. Hundreds of thousands of tons of magma came out on the surface of the ocean floor. After that, a huge underwater volcano with a height of 2,700 feet was formed near the coast of Madagascar. This is almost twice the height of the Empire State Building, and all this is hidden under the water. French scientists studied this place since it had regular seismic activity. When the geologists went on an expedition to the coast of Madagascar, they discovered this giant underwater rock, which was not here until recently. With the help of geological equipment, they discovered the earthquake happened deeper than usual, below the Earth's crust. Geologists created a special observatory to monitor the situation at this site in real time. Between February and May 2019, they recorded about 17,000 seismic activities below the ocean floor. Scientists had never recorded such deep earthquakes. This suggests that there are reservoirs and drainage systems inside our planet through which magma flows. It's like the veins and vessels of a living organism. The volume of lava the volcano spews at this place can be compared with the volcanic eruptions in the hottest spots of Earth. Perhaps this is one of the most catastrophic, but at the same time, beautiful events in nature over the past few years. To understand what can be beautiful about this, let's first figure out what an underwater volcano is and how it works. Inside our planet, there are incandescent liquid metals and molten rocks containing almost all the chemical elements from the periodic table. All this hot substance is called magma, which constantly flows in the planet's bowels. Anyway, magma is lighter than the surrounding Earth's crust, so it always tries to break out upwards. Fortunately, the surface of our planet is strong enough and doesn't allow magma to splash out. But sometimes it happens, and here's why. The Earth's crust consists of many solid parts, tectonic plates. These plates collide with each other because of movement. Imagine a massive picture of puzzles. Each detail of this puzzle is a tectonic plate, and they all are constantly moving. Sometimes one puzzle gets unhooked from another. When this happens, magma immediately spills out of the resulting gap. And these places of faults with flowing magma we call volcanoes. When such a volcano erupts, a new geology begins. A splash of magma shakes the ocean floor. Lava and ash erupt from the inside of our planet. It causes a release of destructive energy of incredible power. But thanks to the water, such a catastrophe can go unnoticed. More than 70% of the seismic activity associated with volcanoes occurs underwater, and almost no one notices it. But inside the water, there's a total mess. Lava heats the water and destroys the seabed. The ocean in this area boils, and large air bubbles rise up. But the enormous pressure of hundreds of millions of gallons of water suppresses the volcano's destructive power. Molten rocks of the Earth's crust are pressed against the seabed. The ocean blocks the consequences of the disaster, but sometimes the eruption gets to the surface. Such a case occurred in 2012. Vast pieces of pumice the size of a van began to float up in the southeastern Pacific Ocean. There were hundreds, even thousands of them. It was more like a group of unknown islands. Volcanic rocks scattered in the ocean over an area twice as large as New Zealand. Scientists used deep-sea sonar apparatus on the remote control to determine the full scale of the disaster. They studied the seabed for a long time and found 14 craters that released lava. The researchers saw that more than a third of the erupted volcanic material surfaced and scattered throughout the ocean. The rest was scattered along the bottom. It destroyed all marine life in the area. However, after the eruption of volcanoes, life is reborn like a phoenix from the ashes. Volcanic ash, lava, and soil around the volcano contain many useful elements and minerals. They nourish the soil and promote the development of microorganisms not only on land but also in water. That's why there's so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form natural islands. This is a long process, resulting from which a large piece of land comes out of the water. When magma goes out, the water immediately presses it to the seabed. The eruption can go on for a long time. The released magma raises the level of the seabed. After another 100, maybe 1,000 years, a new eruption begins. New magma flows lay a new layer on the surface of the previous one. Over millions of years, layer by layer, the volcano has been growing. It's slowly rising up because of constant eruptions. Some volcanoes may go out forever, and some continue to erupt. And then, one day, the level of volcanic rock reaches the surface in the form of a huge island. After many more years, the volcano may go out, and then life appears on the formed island. The destroyed seabed area is filled with animals, trees, flowers, and plants. These volcanic islands have unique ecosystems because they develop separately from all continents. Observing such islands helps scientists understand how life on Earth was born. There are hundreds of islands around the world that have appeared because of eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, and Iceland. Many of them are inhabited by people. They build villages and small towns there. The ground on such islands is fertile. Fruits and vegetables grow there. The water is filled with fish. Such places may seem like paradise, but at the same time, it's dangerous to live there because the volcano may wake up. One of the most famous eruptions occurred on the island of Ogashima, south of Tokyo. People built a beautiful city right in the crater of an active volcano. And in May 1785, the eruption began. No one expected this to happen. At some point, thousands of birds rose and flew away from the island, and then the ground began to shake. A heavy, low sound came from beneath the underground depths. Thick smoke escaped from the top of the green volcano. The mountain threw dirt, large rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People managed to evacuate, and then there was a long recovery. Locals rebuilt the houses and brought the city back. Almost 250 years have passed since that moment, and during this time, the volcano has never woken up. Despite the risk of a new eruption, people continue to live there. The population is growing since this place resembles paradise, and no one wants to leave it. There are thermal springs, dense jungles with rich soil, and many fish. Meteorological and seismological services constantly monitor the volcano's activity. Movements and fractures of tectonic plates create another natural disaster: destructive tsunamis. Unlike volcanoes, huge waves are formed when seismic activity causes the crust to move vertically, up or down. When this happens, water pressure shifts on the ocean floor, which releases energy. This energy pushes the water and creates a tsunami. By the same principle, you form a small wave when you throw a stone into the water. First, a small tsunami appears. Then it picks up speed and increases in size. Its height can reach the level of a 5-story building. It's heading for the coast and accelerating to 500 miles per hour. This is almost twice as fast as a Formula One race car. Millions of gallons of water, weighing thousands of tons, are getting closer. And now the wave reaches the shore and demolishes everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. Such tsunamis are a frequent occurrence on the coast of Japan. People have built massive shields near the land to stop the waves before they hit the shore. Still, in spite of all preparedness, somehow, nature always prevails.
Mirror check. You've got your beige parka on, your chisel is packed, and your overnight plane ride to Saudi Arabia is booked. You know what this means, right? Unfortunately, you weren't cast in the remake of Dune. It just means that you're ready to go explore the world's largest desert areas in the hopes of uncovering prehistoric secrets about our ancestors. Let's get one thing straight. If you ever thought that deserts were empty spaces, think again. They might be filled with sand as far as the eye can see, but they also hold a lot of history. You know, because before humans settled down in cities and towns, we were nomadic people, and we traveled all around the globe looking for food, water, and shelter. So we had to come up with some interesting stuff to survive. Like this thing that was found in the desert of Saudi Arabia. Do you have any idea what this could have been? Over many years, scientists have discussed the origins and use of huge structures such as these ones. It seems our Neolithic ancestors were way smarter than we gave them credit for. They didn't spend all their hours around the fire carving weapons out of stone. No, they were also practicing their architectural skills. These huge stone structures are called desert kites, because if you look at them from a distance, well, they sort of look like kites. Archaeologists have arrived at the consensus that these kites were used to lure animals in. This way, it would make it easier for our ancestors to guarantee their week's food. But that's not all. Take a look at these monolithic structures right here. They show us that our ancestors probably drew on rocks, the blueprint of what they were going to build on the ground. Just like modern-day architects, desert kites could be miles long, so they drew out a plan before actually building them. The most surprising feature of all is that these kites were built even before things such as Stonehenge. We're talking around 7,000 to 9,000 years ago. Over the last decade, scientists have been able to identify over 6,000 desert kites spread across the Middle East and West and Central Asia. If you don't think this huge, try building something this large without the help of any drones. It looks like a pretty difficult feat to me. And apparently, Saudi Arabia's desert is filled with more amazing things. Scientists have found mysterious stone structures that are older than the pyramids of Giza in Egypt. So of course, you can't wait to go check that out. Can we all agree that carrying around heavy rocks to build a pyramid without the help of modern technology sounds absurd? I mean, how on earth did they do it? Now imagine turning back the clock about 2,000 years into the past and finding humans that built similar gigantic structures in isolated areas. Take a look at these so-called mustadils. They are rectangular structures built from piled-up stones, found over 77,000 square miles. Some archaeologists believe that these monuments were used for ritualistic purposes, maybe processions of some kind, where people would walk from one end of the plateau to the other. I'd be down for that. Now let's move on to another deserted area. We're entering the world-famous Sahara Desert landscape. Isn't it beautiful? Here, you're about to unravel an ancient mystery, something that took years for researchers to solve. Fun fact, the Sahara Desert is the world's largest hot desert. It spans over 3 million square miles, which would be like putting 1,000 times the country of Hawaii next to each other. We say it's the largest hot desert because the world's largest desert area is Antarctica. But we all know temperatures over there are freezing, not the typical image of when we think of a desert. Deep into the desert, near the Algerian town of Fougeret et Zoua, something strange was found. For decades, these tiny dots appeared on images of Google Earth, but nobody could explain what they were. Some scientists were sure that these circles are the result of oil activity in the region. Others guessed that these were ancient fogeras or ancient water wells. There are dozens of them, stretching for miles and miles in a straight line. The strange thing is that they are always far away from any town, road, or human activity in general. So what was or is their purpose? If you had to take a guess, what would you say? Remember we talked about how our ancestors had to be creative in order to survive in the desert? Let's try to walk in their shoes for a minute. Imagine you're a nomadic hunter-gatherer living in a desert area. You spend your days basking in the hot sun, trying to count all the grains of sand around you. But you also need to eat and drink water. But how on earth do you get water in a desert? Sure, you can hope to keep running into oasis every week or so, but that seems a bit risky, doesn't it? That's why North African people invented the so-called fogeras. The fogeras are a 2,500-year-old irrigation system. Locals would dig deep wells in elevated areas, wells deep enough to tap into underground water. Then, they would dig parallel shafts at regular distances. This way, the water would flow from the main well down into all the shafts and irrigate entire areas. Travelers could stop by the shafts and quench their thirst. They could also raise livestock and tend to crops. Pretty clever, huh? As much as these holes did look like fogaras, a little bit of research would show you that they're not. You see, these shafts were built in a line, and not in a circular shape like the ones we're looking at now. So maybe it has something to do with the second option? Maybe these desert holes were related to oil activity in the region? Let's have a look at the holes up close and personal. From Google Earth, they don't seem that big, but in real life, they are huge craters. The tip to uncovering what they are is hidden beneath the sand. If you were one of the researchers originally uncovering the truth behind this mystery, you would have found something unique hidden in the sand. Old dynamites and vintage sardine cans. Putting the pieces of the puzzle together, scientists found that these sardine cans were a model from the 1950s and 1960s. It seems that entire teams from that decade would camp out while they surveyed the area for oil. And what about the dynamites? These were used for seismic surveying. This is an old technique, used to identify if there is oil and gas beneath the Earth's surface. Still in North Africa, you find out about another desert mystery worth exploring. Near the city of Tiaret, southwest of Algeria's capital, one runs into 13 peculiar monuments. These structures are also called jedars, and yes, I am aware of how much that may sound like a Star Wars reference. They are pyramid-like in their shapes, and as far as scientists know, they were used as final resting places for the people who lived in the region. Can you guess who these were? Most likely the Berber nomads. And since we're talking about ancient stuff, they were probably built between the 4th and 7th centuries CE. Once scientists began to explore the insides of these monuments, they found they were pretty big inside. They found large underground vaults, chambers, and labyrinth-like corridors that gave way to over 20 compartments. It could take you up to 2 hours to walk around in them, and apparently our ancestors also used its walls to depict images of animals and hunting scenes. There's no definite proof of what these jedars were used for, though. This is so neat, huh? I'm sure that our world's desert is filled with many more mysterious things for us to unravel. I guess I'll see you next time so that we can continue our—
Phew! This summer has been turning up the heat like never before. We feel like roasted marshmallows on a sizzling grill. Yes, the world is getting hotter, but some regions have always fought with high temperatures. It turns out people had some inventions to keep themselves cool in ancient times too. Some of them are still functioning, even 3,000 years later. Let's take a look at how people saved themselves from heat throughout history. So, put Put an ice cube into your cold drink and get ready to hear how people survive the heat. Speaking of ice cubes, do you know that the Persians made an ice storage system? In the deserts of ancient Persia, people had an out-of-the-box idea about how to prevent their food from turning into a melted mess. These ingenious Persians stumbled upon a physics trick that allowed them to create ice in the middle of the desert. They called these cool structures yakhchals, which basically means ice pits. These ice pits were not your ordinary coolers. They were like secret underground fridges. They looked like dome-shaped mud brick structures on the outside, but inside, it was a whole different world. These ice pits had an evaporation cooler system that worked like magic. At night, when the desert cooled down, Persians made use of the radiative cooling effect. They set up cleverly designed trenches to hold thin layers of water. The water froze, defying the desert heat. Then there were underground square storage areas. The Persians collected the melting ice water from these cooled trenches, and during the night, they froze it again, making the most of the desert's natural chill. To add to the cooling effect, they built a wall to shade the storage areas from the hot midday sun. And that's not all. They had this fantastic wind-catching contraption called a badger that caught the breeze and directed it right into the ice pits. Fresh air plus ice. Cool breeze. A winning combo. They even had intricate water channels called qanats to bring water to the ice pits and homes all the way from the nearby mountains. As time passed, these yakhchals faded into history and modern technology took over. But hey, there's good news too. Some awesome folks in Iran are restoring these ancient coolers. So, if you ever find yourself in the desert, don't forget to pay a visit to these marvelous places and witness the genius of the ancient Persians firsthand. Now, I want to focus more on the wind catchers because they don't just help make ice cubes. They actually function as a cooling system as well. Back in the day, those clever architectural wonders were all the rage in places like Persia, modern-day Iran, Egypt, and the Middle East. Imagine tower-like structures with openings at various levels strategically placed to harness the power of nature's breeze. These openings were like magical portals for the wind. They captured those refreshing gusts and guided them right into people's living spaces. Basically, they were natural air conditioners. The breeze would gracefully flow downward, cooling the ground as it danced through the building. The secret sauce lies in the details. The tower's height, the number of sides, the openings, and the positioning of the interior blades. Everything plays its role in how efficiently the wind towers work out. Thanks to these wind catchers, ancient societies could enjoy comfy indoor temperatures without sweating. Can you imagine living in those times? Feeling the gentle breeze whisking through your home, keeping you feeling fresh and chilled out? The Persians are often credited for inventing these awesome wind catchers. But hey, don't forget about Egypt. There, you can find traces of similar structures dating all the way back to 1300 BCE. Yes, the invention of wind catchers may have occurred in ancient Egypt, but Yazid in Iran is the city with the largest number of wind catchers. People wouldn't have been able to live there without these ancient ACs because there was almost no rain in the area throughout the year. Now, let's look at these perforated double-skinned exteriors. Imagine dressing up a building with a fancy perforated screen. It's like giving its exterior a stylish makeover while keeping things chill inside. This genius technique, firstly, scatters the natural daylight, so no harsh sunbeams to blind you. The screen also offers shade like a pro, giving the building's interior a much-needed break from the blazing sun. Think of it as a natural sun hat for your home. Placing this screen about 4 feet away from the outer walls creates a breezy, dreamy hallway for fresh air circulation. And hey, they add a touch of elegance to the building too. These structures are sometimes called jali. Jaipur, India, for example, has an average daytime temperature of about 100 degrees Fahrenheit. So these structures are lifesavers. Jalis come in various forms, crafted from cement, earth, and wood. It's a cultural symbol deeply embedded in Indian architecture. You can find its captivating presence in iconic historical buildings like the majestic Taj Mahal and the Grand Red Fort in Delhi. But hey, it's not just a thing of the past. It's still rocking modern architecture scenes, and its charm has sparked creativity in artists and designers worldwide. It adorns the building's exterior, its cross-section showing a larger opening on the outside and a smaller one on the inside. This is where the Venturi effect steps in to show off its physics prowess. As the air flows through the narrowing passage, it picks up speed, creating a difference in pressure between the inside and outside of the building. Air blowing at a higher speed gets compressed, and when released, it cools down. Mashrabia is a wooden lattice or screen used in the Middle East and North Africa. These decorative wonders are like window blinds, but they do more than just look pretty. They're smart too. They give privacy, shading you from the sun, and let fresh air and light in. Some people also add clay pots filled with water, sand, or damp straw to their designs. As hot air breezes through the holes, it also passes through the pot's porous surface. The moisture inside evaporates, cooling the air. This is a perfect low-cost technique for hot and dry climates. It's eco-friendly, and there's no need for electricity. Now, let's fast forward to today. Designers are getting creative, mixing traditional wisdom with modern tech. At the Al Bahar Towers in Abu Dhabi, they've got it too. Picture over 2,000 hexagonal panels that dance with the sun's movement, providing shade to the building's interior. Water evaporation was another secret weapon for ancient people. Simple, yet super effective. Plus, ancient Egyptians hung wet mats and curtains in doorways. When the air passed through them, it cooled down, providing a relief from the scorching sun. Ancient architects were the masters of maximizing airflow. They knew how to cross-ventilate and let hot air escape while inviting cooler air to the party. Speaking of ancient Rome, bathhouses were the place to be back then. It was like a community hub. People gathered to chat about politics, play sports, and, of course, take a relaxing dip. The frigidarium was the cool spot in Roman baths. After a steamy soak in the caldarium, Romans dashed to this giant pool to chill out. Then in some places, like Cappadocia in Turkey, people went underground to hide from the heat. They carved cozy dwellings in volcanic rock, harnessing the Earth's natural cooling powers. So the lesson here is simple. Architects and designers can create wonders by combining local traditions with smart tech. California's Death Valley boasts the highest officially registered temperature to date, with 134 degrees Fahrenheit in 1913. Meanwhile, Africa's sweltering record stands at 131 degrees Fahrenheit in Kebili, Tunisia, as noted in 1931. In Europe, the highest temperature ever documented reached almost 120 degrees Fahrenheit in Sicily in August 2021. Then, in 2022, the UK had the hottest summer of all time.
We've all heard of the Sahara. Sure you have. It's the largest hot desert on the planet. A sea of sand covering an area larger than the contiguous United States. But have you ever wondered what lies beneath the sand dunes? To answer this question, we must travel deep into the past of our blue planet. Up until some 6,000 years ago, the Sahara was grassland. Humans were around at this time, not me, spreading agriculture around the planet. In the north of Africa, the color green dominated. Plenty of rainfall meant that there were lakes, rivers, pastures, and even forests. A completely different image of the Sahara from the barren landscape of today. But then, the climate started to shift. The region became parched, and the vegetation started disappearing. The wind did the rest. It took away the fine sediment after there were no plant roots to hold the ground together. Give it a couple thousands of years, and you get a familiar image of the Sahara. sand and rocks stretching as far as the eye can see. But when it comes to volume, only a quarter of the Sahara is actually sand. The yellow sands of the Sahara are just one part of the story. The desert has many other features, such as gravel plains, salt flats, and plateaus. Makes you think if we understand the word desert correctly. For people who study such terrains, geologists, there is only one condition for defining a desert: precipitation. If an area gets little or no rain, then it's considered a desert. The Sahara certainly fits the bill. Its average annual rainfall is just 3 inches. Compare that to the nearly 45 inches a year in New York. When we look at precipitation, this sandy desert is only the third largest in the world. Number 1 and 2 are Antarctica and the Arctic. They are larger than the Sahara by millions of square miles. It sounds odd, but there is more than one type of desert. The first two are polar deserts, while the Sahara is a subtropical desert. But the difference in air temperature are staggering. In Antarctica's interior, temperatures plummet to minus 76 degrees Fahrenheit. Compare that to the highest temperature on record in the Sahara of 136 degrees Fahrenheit. But this desert has a cool side. At night, the temperature is roughly the same as the average yearly temperature in Denmark. This hot and cold roller coaster makes it hard to choose the right outfit when venturing into the Sahara. And what about the sand? How deep is it actually? The depth varies between 70 and 140 feet. That's not too deep. If you put the Statue of Liberty in a tall dune, half of it would still stick out of the sand. Its vast amounts in the Sahara were created by aeolian processes. That's Greek for wind. Over time, it blows and shapes the surface of the earth. In dry areas with sparse vegetation, winds erode the ground much faster. That's what happened in North Africa. Under all that sand is the bedrock and cracked clay. If you started digging, you would find the same everywhere on the planet, with one important difference. There is some type of soil covering the bedrock. This is not the case in the Sahara. Because of the arid climate and a lack of vegetation, sand covers the ground below. Over the course of thousands of years, a lot of interesting finds ended up in the desert sand. For example, there are petrified tree trunks. These are essentially preserved prehistoric trees. They date back to the time when the region was lush green. In some places, the trees of this fossilized forest are at least 65 feet tall. The wood is so well preserved that you can still see the texture and knots. There are even fossilized pine cones. In 1992, scientists found glass fragments in eastern Sahara. These canary yellow glass shards were scattered across hundreds of miles. They didn't belong to an ancient civilization, although ancient Egyptians used them to make jewelry. In fact, the breastplate of King Tut had a beautiful scarab beetle centerpiece made from this desert glass. For a long time, scientists were puzzled about the true origins of these fragments. They finally concluded that the glass was around 29 million years old. It is an impact tape. If that sounds like it has something to do with the word impact, you are correct. These rocks are formed when a meteorite hits the surface of the Earth. This generates a lot of heat. Scientists estimate that the temperature needed to melt this mineral was close to 3,000 degrees Fahrenheit. Apart from the regular fine-grained sand, we also have melted sand in the Sahara. But the desert conceals other unlikely artifacts. Shark teeth are a common find in Morocco, which sits in the western part of the Sahara. What are the fossilized teeth of these marine predators doing in the middle of the desert? This part of the world looked entirely different millions of years ago. There was a sea cutting right through what is now a desert. The Trans-Saharan Seaway ran the length of present-day Algeria and Mali. It was around 165 feet deep. That was enough for all sorts of aquatic animals to inhabit it. Large catfish, sea snakes, and of course sharks lived in the area. British archaeologists even unearthed a turtle shell in Mali in the 1980s. For centuries, there was even an entire city hidden under the desert. Timgad was a Roman outpost constructed by the Emperor Trajan around the year 100 in the current era. For various reasons, its residents abandoned it around the year 700. The sands of the Sahara soon engulfed the city. It had remained hidden for nearly 1,000 years. Then, in the 1700s, a Scottish explorer started digging out the city. His team first uncovered a sandstone triumphal arch 40 feet high, similar to the ones we can see in Rome and Paris today. An amphitheater soon popped out of the sand, and it was followed by well-preserved statues of Roman emperors. The Scotsman's find was so impressive that no one believed him at first. It took 2 more centuries for archaeologists to fully excavate the city during the 1950s. The site covers a surface as large as 10 polo fields. The ruins reveal the full mastery of Roman city planning. All the streets meet at a right angle in what is known as an orthogonal grid. You can find the same layout in modern cities such as New York. Historians estimate that during its heyday, 10,000 people called Timgad home. Different nationalities lived here, from Romans to people of African descent. Today, more than 2.5 million people live in and around the Sahara. They are spread across 11 countries in total, and their living space is growing. The desert is 10% larger than it was just a century ago. This process doesn't involve sand pouring out of the Sahara. The ecosystems on the edges of the desert simply change over time. The wind blows the soil away and vegetation dwindles, the perfect conditions for the formation of a desert landscape. These changes are happening in the Sahel, a region south of the Sahara Desert. That's why the African countries have recently come together for a project called the Great Green Wall. The primary goal is to stop the desertification of the Sahel and hold back the sands of the Sahara. Their plan is ambitious and involves planting a wall of trees from the west to the east of the African continent. The proposed forest is not only going to be long, but wide as well. The Sahara and the Sahel share a historic bond. Since antiquity, camel caravans have been making the journey from Africa's Mediterranean coast in the north to the savannas in the south. The golden age of this trade kicked off in the 9th century. The perilous journey took several months to complete. The route was 2.5 times longer than the length of the Grand Canyon. Explorers still find evidence of these ancient caravans hidden away under the sands of the Sahara. Okay, let's try something together. Open any world map you have available. It can be the one you find in your bookcase or even an online version. Take a look at the vast area covered by water. That's 71% of the Earth's surface. And all of that is salt water from the world's oceans. There aren't any borders between the 4 oceans we've all come to know, but oceanographers and the world's countries did traditionally split these waters into 4 distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. And here comes the big surprise. The scientific community has recently recognized the 5th body of water. It's called the Southern Ocean, and 3 of the 4 original oceans border it. It circumnavigates Antarctica and the lower portion of the globe and reaches Australia and the southern portions of Africa and South America. What makes this ocean so special? How did the scientific community eventually recognize it? And more importantly, what mysterious creatures does it hide? Let's find out. The Antarctic Ocean, or the Southern Ocean, was first mentioned back in 1937 in the 2nd edition of the International Hydrographic Organization's Limits of Oceans and Seas. That's a mouthful. Back then, this organization considered that it was wrong to consider the Antarctic Ocean as its own distinct body of water. Why? Well, because at that time, an ocean was defined as water surrounded by land and not water surrounding land. However, they reconsidered it in 2000 and voted to include this ocean in the official list. They also decided on the name Southern Ocean over the commonly used Antarctic Ocean. Finally, the organization concluded that the ocean should be considered as ending at the 60th parallel south latitude. But how old is this ocean? Well, many specialists believe it to have formed only 30 million years ago, which would make it the youngest of the world's oceans. It was created when Antarctica and South America moved away from each other during the early stages of our planet's development. This unique water current is a distinctive component of the Southern Ocean, as it helps keep the waters flowing around the icy continent. It's called the Antarctic Circumpolar Current, and it moves to the east with incredible speed. It's estimated that it moves an enormous amount of water per second. Some of the disputes regarding the Southern Ocean also have to do with this amazing current. Some specialists believe it separates the water of the Southern Ocean from the waters of the nearing Atlantic or Pacific. Only the rapid circulating water is considered the Southern Ocean. On the other hand, though, a handful of scientists say that the current actually makes the naming issue more complex by not limiting the waters to a specific geographic location. They believe that the waters in the current are different in terms of composition from waters in the northern oceans because they are way colder and have a lot more salt. Sailors don't really like this new body of water, mostly because of the frequent cyclone-like storms that it experiences. They happen because of the big temperature difference between the ice packs and the ocean waves. As a result, these storms are very difficult to surpass for any sailors that happen to encounter them. I mean, really, these are the strongest winds found anywhere on our planet. More so, the vessels going through this area must also be wary of the frequent icebergs that may pop up every now and then, and also of the low surface temperatures. Just to paint you a better picture, some of the icebergs found here can span over several hundred meters and can exist all year round, regardless of the season. The latitudes from 50 to 70 have even earned the nicknames of Furious 50s or the Shrieking 60s because of these intense year-round storms. Even the landscape is unique. They say the Southern Ocean has bluer glaciers, colder air, and more intimidating mountains than anywhere else in the world. Now, let's get to the mysterious creatures that call this place home, as thousands of species of wildlife live only here and nowhere else in the world. Let's start with the quirky sea pig, or one of the sea cucumbers as it's sometimes called. There are a lot of them in the waters off Antarctica. Why is it called that way, though? Because of its pink hue and round, bloated looks. On a closer look, it even appears to have a little tail and set of ears, just like a pig. They do help a lot with the quality of the waters here, filtering sand and sediment. Then there are the Hoff crabs that live on the floor of the Antarctic Sea. The Southern Ocean is a cold water environment, but crabs are more adapted to warmer waters. So, Hoff crabs gather around the warmth made by volcanic vents. They get the needed warmth and food here. You can find them in large piles, one on top of another, literally filling the space of the vent openings. Now, wonder how they got their unofficial name? Well, it's because of their apparent similarity to the actor David Hasselhoff, whose impressive chest reminded explorers of the crab. Okay. Ever seen a fish that's completely transparent? You'd have to get to these waters down in the south, but they do exist, and they are simply called the ice fish. You can basically see inside them, being completely clear and all. That's because of their see-through skin and because they don't have any red blood cells. Their special power is that they can use antifreeze to prevent their bodies from going solid in the cold waters of the Southern Ocean. Instead of the standard thicker blood, the red one with hemoglobin, ice fish have thinner blood that moves around more easily throughout their bodies, hence giving them the much-needed nutrients and oxygen. Now, is there a monster hidden in these waters? Some people believe this to be the case, and thanks to recent research, we even have video footage of it. Some Australian researchers stumbled upon a bunch of weird-looking creatures that were swimming near the seafloor of the Southern Ocean. This pink blob-like fish seemed to be propelled by a little pair of fins. To quote them on it, it seemed to resemble a chicken just before you put it in the oven. I'm not sure I even want to know what that looks like. It took them some time and research to identify the monster. It's a shy species of sea cucumber, known more by its creative nickname, the headless chicken monster. We've known this creature has existed since the late 1800s, but we've barely ever seen it. And we've only ever captured it on tape once before when it was spotted in the Gulf of Mexico, which is quite far from the waters off the coast of East Antarctica. There's so much we don't know about this creature, like how many of them exist in our waters and how they live, eat, and reproduce. Ever heard of the emperor penguin? It's not a penguin species that just happens to have a crown on its head, if that's what you're thinking. But they are one of those penguins that inhabit this specific location and are also the largest species of their kind altogether. What makes them special is that they make their colonies on the sea ice, and most of them never step foot on land. More so, penguin dads lose almost half their weight while incubating the eggs. They're also fascinating swimmers, able to dive deeper and longer than any other bird, up to 700 feet. Not to mention they can stay submerged for up to 18 minutes at a time as they gather food. We have yet to uncover all the secrets of the mysterious Southern Ocean, but it's clear that it's home to some unique and fragile marine ecosystems. Recognizing it as a new ocean could be one way to focus the public attention on it and help its conservation. You know, oceans cover around 70% of Earth's surface, and we have only explored 5 to 20% of them. And now, astronomers have found more water, a huge stash floating out there in space by a quasar that's more than 12 billion light-years away. And we aren't talking about just a little puddle. It's a mind-blowing amount of water, about 140 trillion times more than all the water in Earth's oceans combined. It's hanging around a supermassive black hole that's a staggering 20 billion times bigger than our Sun. This black hole is surrounded by a super bright quasar. It gives off as much energy as you get if you gathered 1,000 trillion suns. I can't count that high. Oh, by the way, since light takes time to reach us, we're seeing this quasar as it was when the universe was still very young. Astronomers are sure that the newly discovered water reservoir is the farthest and biggest we have ever found in space. Mark Bradford from NASA's Jet Propulsion Laboratory explains that the environment of this quasar is so unique that it's capable of creating an incredible amount of water. Bradford's team, along with another group of astronomers, has been studying the quasar and the supermassive black hole at its center for quite some time. They've noticed that as the black hole pulls in surrounding matter, it heats up the nearby gas and dust. This process has created a region packed with molecules that have never been observed at such a great distance before. Now, quasars were first spotted around 50 years ago, when telescopes picked up super bright objects way out in space. They're not regular stars. They shine from the centers of distant galaxies and are so powerful they outshine all the stars in their galaxy combined. At the heart of every quasar is a gigantic black hole, which is millions or even billions of times heavier than the Sun. When gas and dust swirl toward the black hole, they heat up and release an insane amount of energy. It makes quasars some of the brightest and most powerful things we've ever seen in space. Looking at quasars is like looking back in time. The light we see from them today has been traveling for billions of years. It gives scientists a peek at what the universe looked like way back in the past. Quasars can help us understand how galaxies formed, how matter spread out, and how the first cosmic structures came together. Some quasars shoot out massive jets of superfast particles. Stretching across space, they can sometimes change entire regions of the universe. But let's get back to that space water, or rather water vapor. When astronomers discovered it, it was floating around the quasar, spread across a huge area hundreds of light-years wide. For comparison, just 1 light-year is about 6 trillion miles. Even though the gas there is incredibly thin, unlike what we're used to on Earth, it's much warmer and denser than the gas found in most other galaxies, including our own Milky Way. The temperature of this gas is around -63 degrees Fahrenheit, and it's about 300 trillion times less dense than Earth's atmosphere. It does sound extreme, even in space terms, it's unusual. Now, water vapor isn't just another molecule. The very fact that it exists near the quasar hints that the area is regularly blasted with radiation. That's what keeps the gas warmer than usual. To add to the mystery, astronomers also found carbon monoxide and other molecules. In other words, there's plenty of raw material floating around. In the future, this gas could help the supermassive black hole grow even bigger, up to 6 times its current size. But that's just one of many potential scenarios. Some of the gas might get pulled into the black hole, some could form new stars, and some might even get flung out into space. Now, finding water vapor in such a distant quasar means that the basic building blocks of the universe have been around for billions of years. Water is crucial for life as we know it, so its presence so long ago hints that the ingredients for life existed much earlier than we might have thought. But water isn't just important for life. It also plays a key role in how stars and galaxies form. When giant clouds of gas cool down, water helps them collapse, making it easier for new stars to be born. But how did researchers even spot this massive cloud of water? In 2008, Bradford's team started looking for water in space with the help of a special instrument called Z-spec. It was attached to a 33-foot telescope in Hawaii. To double-check their findings, they used another powerful tool, CARMA. That's a group of radio dishes in the mountains of Southern California. At the same time, a different team was searching for water using a telescope in the French Alps. In 2010, the second team found a small hint of water in the distant quasar. It was just one teeny-tiny signal. After that, Bradford's group detected more signals. It was all the proof we needed to conclude that an enormous amount of water was actually out there. Now, our floating cloud of water vapor isn't the only place where we've found water beyond Earth. Scientists have recently made a huge discovery. It turns out there are massive reserves of liquid water hidden deep underground on Mars. So, in theory, future astronauts could use this water to support missions or even make Mars a long-term home. But of course, there's a catch. This water isn't sitting in nice, accessible lakes or oceans. It's buried so deep inside Mars that we have no way of reaching it with current technology. Scientists have figured this out by analyzing seismic data from the Mars InSight lander. It picked up some strange seismic activity, and the best way to explain it is by these hidden water reservoirs. Mars still does have some water today, mostly as ice on or just beneath the surface. But that's nothing compared to the massive amounts of water the planet had billions of years ago. The big mystery is, where did all that water go? Scientists think it could have either escaped into space or moved into the planet's interior, where it might now be trapped as liquid reservoirs or ice deposits. The problem? We have no way of measuring how much water Mars lost. So for now, that question remains unanswered. Earth's moon has water too, but not in the way you might think. Instead of lakes or rivers, the moon's water is mostly frozen ice, spread out unevenly across the surface. The cold, shadowed poles are especially full of it, since they never get sunlight. A lot of this ice is also mixed in with lunar soil and buried deep underground, making it super tricky to get to. Then there's Enceladus, one of Saturn's moons. It's tiny, just 314 miles across. It's small enough to fit inside Arizona. I think we should try that. Anyway, when NASA's Cassini space probe arrived at Saturn, scientists expected Enceladus to be a barren, frozen world. But instead, they saw huge plumes of icy particles and water vapor erupting from geysers near the South Pole. That meant there had to be a massive ocean hiding beneath its icy shell, sandwiched between the moon's rocky core and the frozen surface. The fact that this ocean is active and constantly sending material into space makes Enceladus a top candidate for future exploration. We also have Europa, one of Jupiter's moons, and one of the most promising places to search for alien life. Europa has a gigantic saltwater ocean that could be 40 to 100 miles deep. This means it might hold more water than all of Earth's oceans combined. But there's a big obstacle. This ocean is hidden under a thick ice shell, which scientists think is 10 to 20 miles deep. Europa's ocean stays liquid because of tidal forces from Jupiter's gravity. The planet's massive pull stretches and squeezes the moon, creating friction, which heats up the interior, stopping the ocean from freezing solid. And the most exciting part is that scientists think water plumes might be erupting from cracks in Europa's ice, shooting ocean water into space. Now, if that's true, we could potentially sample the ocean without having to drill through miles of ice. But there are still a lot of unknowns. How big are Europa's water reservoirs? How quickly do they refreeze? And how does the intense temperature and pressure affect the ice? Scientists are eager to figure this out because Europa's ocean is one of the best bets we have for finding extraterrestrial microbes somewhere in our solar system.
Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next ice age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt, wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity, that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turned to the deep sea. They studied changes in oxygen isotope ratios found in the tiny, fossilized shells of marine creatures. These tiny creatures live in the ocean, and their exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. but it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder, turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. The Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The US East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the US East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100. Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak, but it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960. And it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn! For years, scientists have been struggling to explain bizarre sounds, some repeating, some heard only once, that come from the dark depths of the ocean. From bewildering hums to worrying bloops, the water transmits outlandish acoustic phenomena. One of these mysterious noises got named the upsweep. For the first time, this long train of sounds was registered in 1991 in the Pacific Ocean. One of the most unusual things about this signal is that it keeps changing, as if trying to confuse researchers even more. Like some unearthly howl, it varies from high to low frequencies and then back again, and you can hear it better in the spring and fall than in the winter and summer. Why the upsweep? It's simple. The sound travels from the bottom of the ocean towards its surface, as if sweeping up. Scientists do have a theory explaining this phenomenon. the activity of undersea volcanoes. Hot lava pouring into ice-cold ocean water could theoretically create such noises, but there's no proof found yet. Plus, the sound has been declining since 1991, even though it can still be detected. The bloop is the name given to an ultra-low frequency and incredibly powerful underwater sound that was recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The bloop continued for approximately 1 minute. Having started from a low rumble, it gradually rose in frequency. It also kinda mimicked the noise created by marine animals, but its volume was so great that no living creature known to science could have made it. When the bloop occurred, underwater microphones managed to record it from a distance of 3,000 miles away. Rumor has it that the noise might have something to do with the fictional half-octopus monster Cthulhu, or some other colossal deep-water creature. But if you don't believe in monsters, science has another explanation: iceberg fracturing. The thing is that icequakes recorded in the Scotia Sea resemble the mysterious bloop a bit too much for it to be a coincidence. The whistle resembles this annoying sound when a kettle of boiling water is telling you it's time to make a cup of tea. But even though it may not be as blood-curdling as some other bizarre ocean sounds, it doesn't make it any less mysterious. Plus, the whistle is very elusive. In 1997, only one underwater microphone was able to pick it up, and therefore, researchers didn't manage to pinpoint the source of the noise. The most likely cause of the sound is an eruption of one of the submarine volcanoes. Have you ever heard of Julia? No, not your neighbor. I'm talking about this otherworldly sound. Listen to it. It was recorded in 1999 by the U.S. National Oceanic and Atmospheric Administration. The source of the sound was most likely a large iceberg that ran aground somewhere in Antarctica. The sound was so loud that it was heard over a huge territory, and its duration was about 2 minutes and 43 seconds. Slow down. That's the name given to a sound recorded in 1997 in the equatorial Pacific Ocean. The sound was called this way because it slowly decreased in frequency over 7 minutes or so. It's been picked out a few more times since it was recorded for the first time. The source of the sound isn't very mysterious. Most likely, it was produced by a massive iceberg that became grounded in Antarctica, or it was caused by moving ice. By that, I mean the friction produced by a large ice sheet moving over land. The loneliest whale sound is often called the 52 Hz whale because the animal that creates it calls at a unique for these creatures frequency. When you listen to this sound, it sounds like a low bass note. At the same time, it's much higher than the normal frequency of the whale call, which rings between 10 and 40 Hz. Interestingly, scientists have been listening to the world's loneliest whale for decades, but haven't managed to figure out its precise location. Nobody knows whether the mammal is male or female, what species it is, or if the animal is still alive. After all, for the last time, its call was recorded in 2004. Earth-shaking booming sounds have been reverberating off some parts of North Carolina for more than 150 years. Called Seneca guns, they're most often heard near the coast. The sounds are so powerful that they often rattle window panes and sometimes vibrate entire buildings. They can last from 1 to almost 10 seconds. Even though scientists haven't cracked this mystery yet, there are some theories. They range from earthquakes to severe distant storms and quarry blasts. But even though the ground trembles every time the phenomenon occurs, no seismic activity coincides with these events. So far, scientists have come to the conclusion that the mysterious sounds happen in the atmosphere, not on or under the surface of our planet. If this theory is true, bolides might be the answer. These extremely bright meteors often explode once they enter Earth's atmosphere. Or Seneca guns might be born in the ocean. Sometimes, when enormous waves collide far away from the shore, you can hear it, even if you're nowhere near the coast. Seneca guns are a type of skyquakes. You don't need to travel to a particular part of the world to hear one of those. Mysterious sonic booms ramble from the sky everywhere, from the US to India and Japan. Just like Seneca guns, this sound phenomenon occurs mostly near the coast or a big body of water. Rattling glassware and windows in the nearby houses, skyquakes could be connected with ultra-fast airplanes breaking the sound barrier. But people started hearing the first skyquakes in 1824. The theories trying to explain this phenomenon include sand dunes shifting, meteors entering the atmosphere, distant volcanoes erupting, Earth's crust cracking during earthquakes, and even gas bursting out of underground vents in the sea or lake bottom. In different countries all over the world, people get paralyzed with fear after hearing otherworldly trumpet sounds that seem to be coming from the sky. The inhabitants of the US, Canada, Australia, Germany, and the Philippines have already heard this hair-raising noise since it was first recorded in 2008. These sounds are sometimes called the sound of apocalypse. And although until recently, nobody could understand the origin of the sounds, NASA claims that there is nothing to be afraid of. The noise can be coming from our own planet. Usually, it's quiet and thus inaudible to the human ear. But when it gets louder, the outcome is the very trumpet sounds that scare people all over the world. Bristol hum started in the 1970s when hundreds of Bristol inhabitants began to talk about a bizarre noise audible only at night. The noise was a low-level hum, and nobody could identify or trace the source of the sound. But the strangest thing about the noise was that one day, it stopped as abruptly as it started, but not before people in other towns across Britain reported hearing similar sounds. Some time ago, the mysterious sound returned. In 2015, a group of French scientists claimed that they had solved the mystery of the Bristol hum. They stated that the culprit was ocean waves that made the ocean floor vibrate. But while it was all good and well, it didn't explain why the sound was around for only several years or why it chose to return. If you ever come to the town of Taos in New Mexico, don't let another strange and unexplained phenomenon send you running for the hills. This phenomenon is a faint, low-frequency hum ringing in the desert air and grating on your nerves. Even stranger, only 2% of people who live in Taos hear this noise. But for those who do, it's unstoppable torture. On top of that, everyone describes the sound in a different way, from a quiet whir to an eerie hum or even persistent buzz. And while some people believe that the Taos hum is the result of unusual acoustics, the others suspect a bad case of mass hysteria. No one has located the origin of the hum yet.
So, in the end, will the sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the Earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation Event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation Event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in 1 billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Mozambique cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask. But for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there, and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances. And somehow, life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in 1 billion years.
On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the blue. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. the avalanche broke two seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini-basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini-basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
A huge power outage hit Spain, Portugal, and parts of southwest France all at once, leaving millions of people without electricity. It happened on Monday morning, April 28, 2025, and caused lots of problems. Airports couldn't function, trains stopped in places like Lisbon and Madrid, and some hospitals had to cancel surgeries because they had no power. Everything just came to a stop. No one is sure yet what caused the blackout, but the company in charge of Portugal's electricity said it might have been something strange called induced atmospheric vibration. That's a rare and weird thing that can happen in the sky and might mess with power systems. It occurs when substantial changes in temperature and wind mess with giant power lines, making them wiggle and shake in strange ways. These wobbles can confuse the power system and cause big problems. So REN, the company that runs Portugal's electricity, first said that those weird wobbles might be the reason everything went dark. But later, they said that was not really what happened. According to REN, the real reason for the blackout was a huge voltage change, like a power surge, in Spain's power grid. At that moment, Portugal was using electricity from Spain. When that enormous power fluctuation hit, it triggered automatic safety systems in Portugal. Those systems shut everything down to protect power plants. Sadly, it also caused a nationwide blackout. During extreme weather in Spain, the air temperature changes fast, and that makes immense power lines stretch or shrink like rubber bands. That changes how tight they are and how they move in the wind, which can mess with both their physical balance and the electricity flowing through them, making the entire system unstable. Some experts say that if things get bad enough, this can even break power lines, cause short circuits, or even damage the towers holding up the lines. That's why safety systems are always in place. They're supposed to shut parts of the grid down automatically to stop bigger disasters. During the blackout, something like a domino effect happened. When parts of the power grid shut down, it made other parts unstable too. Some of the big electricity generators couldn't handle the chaos and had to disconnect. And when you suddenly lose those big generators, the power system can't keep up. It's something like too many people needing electricity, but not enough of it being made. It can cause even more blackouts to spread fast. Nobody knows exactly what started the blackout. Some people wondered if it might have been a cyber attack, like someone messing with the system on purpose through computers. But officials from Spain and the European Commission said that there was no proof of that. Spain's electricity company made it clear. Cyber attack? Nope, that's not the problem. Still, one big reason so many places were hit is because Europe's power grids are all connected like one big web. Usually, that's a good thing, since if one country has a problem, another can help by sharing electricity. At the same time, everything has to stay super balanced. The amount of electricity being made must match how many people are using it. If even one part gets knocked out, it can mess things up for other parts nearby, especially if they were depending on it. In other words, when something big goes wrong, it can travel through that web and cause problems in lots of countries at once, just like what happened in this case. And it's not the first time this kind of thing has happened. Back in 2003, most of Italy had no power for 12 hours because of a problem with an electricity line connected to Switzerland. In 2006, overloading of lines coupled with low temperatures caused too much power to surge through Germany's grid, which ended up knocking out power in many parts of Europe. Anyway, speaking of the recent blackout, by Tuesday morning, things started getting better. Most of the lights came back on across the Iberian Peninsula. That's Portugal and Spain. All of Portugal had power again, and 99% of Spain did too. Now, the people in charge are trying to figure out exactly what went wrong and how to make sure it never happens again. So yeah, power grids are awesome when they work. When things go wrong, they can go really wrong. Now, let's travel back into the past, to the year 2012. Long time ago, huh? That's when India had one of the biggest blackouts in history. More than 600 million people lost electricity. That's like half the country or the entire population of Europe. This huge mess happened when 3 enormous power grids all broke down at once. Yep, those very grids that move electricity around. So when they fail, the lights go out everywhere. Because of this, entire cities just stopped working. Trains couldn't move, water pumps stopped, traffic lights went dark, and people were stuck all over the place. In Delhi, the capital city, the metro shut down, and passengers had to be helped off the trains. Without traffic lights, the roads turned into giant traffic jams. The blackout hit 20 of India's 28 states, including big ones like Punjab, Haryana, Uttar Pradesh, Rajasthan, and West Bengal. In West Bengal, around 200 miners got stuck underground because the elevator stopped working. Luckily, they were all rescued safely. Engineers worked all night to fix things, and by the next day, they managed to get the power back on for all 3 grids. In India, smaller power cuts happen a lot, especially in cities. That's because the country doesn't make enough electricity for everyone, and the equipment they use is pretty old. But a full grid collapse like this is rare. Before this, it happened in northern India back in 2001, so when it happened again in 2012, and across 3 grids no less, it was very important. Everything just shut down, and it showed how much the system needed fixing. But blackouts like these happened in Europe before too. Back in 2006, something weird happened because people in Germany got cold. It was a chilly Saturday night, and families in northern Germany turned on their heaters all at once. This sudden spike in energy use put a huge load on the power grid. To make things worse, one major power cable had been turned off for a bit so a ship could pass under it. Ooh, talk about bad timing. The grid couldn't handle everything, and it started breaking down. First, Western Germany had blackouts. Then things started going wrong in France, where even the big French power company, EDF, couldn't keep up with demand. Before long, power was going out in Paris, its suburbs, and other parts of the country. Then the trouble spread to Italy, Spain, and Belgium, and even Morocco. Millions of homes were left without power. In France alone, about 5 million people were left in the dark. Trains stopped running, and fire crews got loads of calls from people stuck in elevators. One of the people in charge said the whole thing started falling apart like a house of cards. Country after country started pulling power from France, which only made things worse. To stop a total blackout across all of Europe, they had to shut down some electricity for a short while on purpose. Over in Italy, the lights went out in both northern and southern regions. This country often imports electricity from other places, so it got hit hard. A few years earlier, in 2003, most of Italy had gone dark during another big blackout. Belgium had its own problems, while Spain saw power cuts in some of their larger cities. Even trains and high-speed rail had to stop in some places. It all started because too many people needed electricity at the same time, and the European power network couldn't keep up. Experts later said that the whole thing showed just how badly Europe needed to update and fix its old electricity systems to stop something like this. So look at this narrow passage between the north of Morocco and the southern part of the Spanish region. It's called the Strait of Gibraltar. There are only 8 miles between the two continents, but for some reason, there's no bridge, despite people having been dreaming for centuries about connecting these two regions. There are places in the world where a bridge over water stretches for a much greater distance. For example, the Lake Pontchartrain Causeway near New Orleans, Louisiana, goes for 24 miles, which is 3 times the length of the hypothetical bridge between Africa and Europe. That's listed in the Guinness Book of World Records as the longest continuous bridge passing over water. It consists of 2 parallel bridges and connects the urban area of New Orleans with small settlements in the north of Lake Pontchartrain. 9,000 concrete piles hold more than 1,000 decks above the water. This large-scale structure was built in the middle of the 20th century. It only took 14 months from the start of construction to its completion. American engineers created a unique technology for attaching concrete piles to the base of the bridge, and this bridge is still functioning. So, what's the problem with building a shorter bridge to connect Africa and Europe? Let's first find out the value of the 8-mile bridge that could connect 2 continents and the reason why everyone is talking about it. In fact, the value of such a bridge would be enormous. Diamonds, oil, minerals, Africa is full of valuable materials, and Europe is happy to buy these things. This theoretical bridge could allow people to transport things for trade quickly and comfortably. But now, the exchange of goods between Africa and Europe is only possible thanks to airplanes and cargo ships, and airplanes are extremely expensive because of hefty fuel price tags. In addition, air travel is often delayed because of bad weather. There are long customs procedures and transportation from the airport to the destination. Ships can also be a problem. The narrow area of the Mediterranean Sea, where the 2 continents are closest to each other, is a dangerous place because of storms and strong currents. The transportation of your diamonds is highly dependent on weather conditions. The second advantage of such a bridge would be the creation of tens of thousands of jobs. People from Europe and Africa would build hotels, ports, parks, and even small towns for each other. The coastal parts of both continents would become a new economic center. And just imagine how much investment those places would attract. Europe and Africa would be much closer than ever before. You could drive from a small Spanish town to a safari park in northern Morocco, buy Moroccan tea, get some argan oil, and go home for the evening. Or you could take a high-speed train across the beautiful Mediterranean Sea. People would open hundreds of restaurants, amusement parks, shopping malls, and a museum next to this bridge. But, unfortunately, it's impossible to build such a bridge, at least at the moment. And here's why. The main problem is the Strait of Gibraltar itself, because of its strong currents and seismic activity. How can you start large-scale construction if, in a couple of days, an underwater earthquake can trigger giant waves and take all the ships underwater? Even if you build a bridge, rapid streams of water that constantly change direction can shake the entire structure and tear the connecting parts of the construction. The bridge over the Strait of Gibraltar must have a strong, sturdy system that will withstand seismic activity. Huge resources are required to create such a complex structure. Despite the dangerous passage between the 2 continents, it remains one of the busiest points in the world. It's the only place on the planet connecting the Mediterranean Sea and the Atlantic Ocean. About 300 ships pass through this area every day. Not only merchant ships, but also fishing vessels and tourist boats. There are not so many places in the world where you can watch whales coming out of the water. Not only people, but also marine creatures often visit this passage because of the peculiarities of the sea currents. But we'll talk about that later. Another problem is the depth of the strait. In simple words, any bridge over the water is built on long metal piles. Builders and engineers stick piles into the seabed and use them as a holding base for the whole construction. But installing such piles firmly enough is a difficult task because of the uneven seabed. The seabed has a unique geological landscape, irregularities, and different densities of the Earth's rock. There are also reefs, rocks, and pits. Any seabed requires extensive geological studies before piles are installed. However, the bottom of the Strait of Gibraltar is especially difficult because of its depth, almost 3,000 feet. It's one of the deepest straits in the whole world. Just imagine, you'll need the height of 10 Statues of Liberty to reach the surface of the water from the bottom of the strait. What kind of pile should be used there to hold the entire bridge? Most likely, one pile will have to consist of several parts connected into one large metal rod. And don't forget about seismic activity. Let's say you've installed perfectly strong piles, but the next day an earthquake occurs and destroys the entire structure. And a strong current is carrying fortifications all over the Mediterranean Sea. The next problem is probably the most important one, because it concerns marine life. The Strait of Gibraltar has a high salt content. This natural element makes water heavier and makes it descend to the bottom of the deep Mediterranean basin. Then, this salt water pushes up cold water from the seabed into the Atlantic Ocean. These changes in water density, as well as fast currents, create sea vortices and turbulence. It's like a raging cauldron of cold water that raises a lot of nutrients to the surface. The hollows and hills of the Strait of Gibraltar are filled with different substances and sunlight, and this creates ideal conditions for the formation of phytoplankton. Whales, dolphins, and other marine creatures adore this delicacy. That's why you can see about 7 species of whales and dolphins in this place. What might happen to phytoplankton after the start of global construction? Carbon dioxide, crushed rock, tons of dust and ashes, falling building materials – all of this could significantly pollute the environment. Without phytoplankton, many fish would go extinct. Without fish, thousands of fishers wouldn't be able to get food and earn money. But even if the bridge was built, cars and trains would continue to pollute the air and water. This disruption of the delicate balance in this narrow strait can lead to larger-scale environmental disasters. Dolphins and whales may leave to look for food elsewhere, and thus take resources from other marine inhabitants. Like falling dominoes, one problem can follow another. And all this because of one bridge. In 2007, the Spanish Ministry of Environmental Protection introduced speed limits for all ships sailing through the strait in order to not disrupt the delicate balance of nature. At the beginning of the 20th century, a French engineer proposed a project of a bridge, but it was rejected because it was too complicated and costly. People also tried to develop a 23-mile-long tunnel, but this project also faced financial and technical difficulties. People are still dreaming of a bridge over the Strait of Gibraltar. Perhaps, in the future, when we develop cooler technologies, we'll be able to build this thing. Oh, by the way, there hasn't always been water between these two regions. In the distant past, the two continents were connected. The entire Mediterranean Sea is the remains of the Tethys Sea that existed before the era of dinosaurs. Then the African and Indian plates collided with the Eurasian one, and the Tethys Sea completely disappeared. In its place, a land bridge was formed that separated the Mediterranean Sea from the ocean. Without access to water, the sea dried up about 6 million years ago. But then, when the bridge came down, the water began to fill the dried-up pool. For tens of thousands of years, the narrow plate sank lower and lower, and the Mediterranean Sea eventually got its current water levels. Most rivers in the world flow into the sea, but the Okavango in Africa takes its massive waters right into the Kalahari Desert. And it looks like this river manages to do the impossible and defies gravity. The Okavango starts in the highlands of Angola, runs for 1,000 miles like any other normal river, and then drops into the largest inland delta on Earth, known as the Okavango Swamp. The delta has land slopes dropping at nearly 150 feet, which is about half as tall as the Statue of Liberty. The area where the Okavango Delta is now used to be part of a lake that dried up around 2,000 years ago. It takes the Okavango water several months to complete its journey, and the landscape there is never the same. The first European to have found the delta was the Scottish explorer David Livingstone. Yeah, the Dr. Livingstone, I presume, guy? That's him. When he first saw it, he was shocked as he noticed that the water seemed to be flowing backward and even uphill. He saw 2 strong watercourses connecting the Okavango to the wetland systems to the east. Decades later, other explorers saw them completely dry. Several years later, the watercourses were full again, and they kept emptying and filling up, sometimes changing direction. Scientists managed to explain this mystery when they found a hidden network of faults part of the Great Rift Valley under the sand. When major earthquakes happen, like the one in Indonesia in 2004, the Earth sets off a chain reaction. Tiny cracks underground shift just enough to send a trickle of water down the river, and a flood begins, raising the water levels. Plus, in May and June, when winter begins in the southern hemisphere, floods bring more fresh water and life to the swamp. Islands get submerged completely during the peak floods and then resurface again at the end of the wet season. Wildlife just loves all the water in the delta, and you can often see migratory elephants bathing among pink lily pads and silverfish, bream, barbels, and other fish. There are lions, cheetahs, buffalo, wildebeests, hippopotamuses, hippopotami, zebras, wild dogs, crocodiles, and other species of animals. Storks, ibis, herons, cranes, and geese like to fly by, along with 450 species of birds. Although the Okavango has plenty of water that is priceless in the desert, people hardly settle along its banks. One big problem here is the tsetse fly. But if you're feeling adventurous, you can come here for a water safari. Scientists from Imperial College in London stumbled upon a totally unexpected river under the Antarctic ice sheet. It slurps up water from an area as big as Germany and France combined. Scientists used to think the lakes under the Antarctic ice were just chilling by themselves. But now it turns out they're part of an interconnected river network. Water under the ice can form in two ways, either from melted snow seeping down or from the Earth's natural heat and the ice grinding over the ground. The Antarctic gets a lot of surface melting during the summer, but Antarctica is usually too chilly for that. This newly found river is proof that there's plenty of water down there just from the ice melting from below. This river could make Antarctica lose its icy cover way faster. If things heat up enough to melt the surface, that water could rush down and mess with the base of the ice sheet, turning Antarctica into a melting mess like Greenland. If the ice starts moving faster than the water can handle, it's going to create more friction, making even more water and speeding up the melting process. The researchers are on a mission to dig deeper into how this river system works and see if it's causing trouble in other parts of the icy continent. Understanding what's going on down there could give us a heads up on how a changing Antarctica might shake up the whole planet. The Roe River in Montana flows for just a bit over 200 feet between Giant Springs and the Missouri River. It was mentioned in the Guinness Book of World Records as the shortest river in the world, but they had to remove this category altogether because there was some heated debate over this title. Residents of Oregon claim that their D River was the absolute champion, as it all depends on when you measure them. There could even be shorter rivers in Norway or Indonesia, depending on what you see as a river. The official definition says it's something that has constant flowing water in the form of a current and is fed by upland sources or another river, lake, or watershed. Creeks and brooks flow together to form streams. Streams become rivers, and rivers take the water from higher to lower lands, ending in the ocean. There are 12 stream orders, and the first two levels don't have other streams feeding them. So, Roe and its other short buddies technically deserve the title of rivers. I'm glad we cleared that up. Rio Negro in South America is the largest blackwater river in the world and the largest left tributary of the Amazon jungle. Its waters look more like strong tea and seem pitch black only from the distance. They get that dark color from humic acid. When plants containing phenol break down only halfway, they leave behind this tea-like hue. Some people believe that blackwater rivers can't be productive, but Rio Negro helps big fishing industries and has spots where turtles come to lay their eggs. Back in the 17th century, explorers didn't find tons of indigenous folks along the river. But it probably didn't have to do with its productivity, more with diseases and conflicts. There are around 700 different fish species documented in Rio Negro's basin, including at least 100 you won't find anywhere else. A bunch of those fish end up in aquariums, like the super popular cardinal tetra. There is a canal connecting Rio Negro and the Orinoco, which is another major river in South America. Many aquatic species try to move between the rivers, but only the toughest can handle the mix of blackwater and clearwater sections in that canal. There's a unique creek in Wyoming that drains both into the Pacific and the Atlantic Oceans. It begins high up in the Teton Range and later splits into two branches. The Pacific Creek joins the larger Snake River, which merges with the Columbia River and finally reaches the Pacific Ocean. The Atlantic Creek heads east and flows into the Yellowstone, Missouri, and Mississippi rivers and eventually empties into the Gulf of Mexico. If you connect the two creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers who were looking for the Northwest Passage between the two oceans never knew they could have used the creek. They would just need really tiny boats. Some scientists believe that cutthroat trout knew about this route long before people. They managed to migrate from the Snake River to the Yellowstone River, most likely using the two-ocean creek. Now, every summer, the Caño Cristales in Colombia turns into a liquid rainbow, or the River of Five Colors. At this time, and until the end of fall, the conditions are just perfect for the riverbed to turn bright red, yellow, green, blue, and black. You gotta thank certain aquatic plants growing in the river, a special type of seaweed for all this beauty. During the wet season, the river moves fast, and the sun cannot get to these plants. When the dry season hits, there isn't enough water to feed them. So, the time in between the seasons has the perfect conditions for this colorful show. No other place in the world has anything similar. So, at some point, the number of tourists who wanted to see it became so huge that scientists got concerned it could be bad for this hotspot of biodiversity. The area is home to rare species of animals, birds, and plants. Now, there are ecotourism trails and strict opening hours for visitors.